Hello and welcome. I'm going to have a look at another one of these Bush RP20 record players that I turn into guitar amplifiers. In fact, we're going to be doing a couple of three of these chassis. So we've got a chassis in this one and we've got a chassis here, and I actually bought a spare chassis for this. There was one being sold on eBay, so I've already stripped this one down. You can see there I've ripped everything out roughly that we need to take out there, like that. And I'm going to do various versions of these, mainly the preamp stage really on these. So this one I'm going to use an ECL80, and then on the other one, which is in here, we're going to try a different design which I'm not 100% sure about. So let's just have a look in here and I'll just go through a bit what we do on these, even down to the badge that's on there, which we stick on the front. There is videos further on the channel that I did maybe a year or so ago. So if you want to view one of these being put together, you can. If you want to view that now, you can go and have a look at those videos. There's a couple on there. We remove the turntable, which is trash basically. Even when these were working, they couldn't have been too great. Incidentally, that one looks like the arm, the cartridge and the arm are all in one. On the others that I've had, they've slotted off. Looks like some of the turntable's gone already, the platter's missing. So if we take this board out, which is unscrewed but wedged in like so, lift this up and we can get a look at the chassis. So we'll completely remove this turntable and we just keep this board and we mount the with the amplifiers mounted on. We put new speakers in these and we reposition the amplifier so it's at the back and not at the front, because with the new speakers we use, which will be here, the chassis will protrude on the back of the speakers. And there you can see there's a wheel off the turntable that's fallen off. Now usually when I get these, they've also got quite good valves in as well, and we usually got mullards in. So let's have a look what we have got there. We can see that looks like a mullard, and it is the Mullard EL84. We'll test these, but because most of these I've done, well, all of them I've used different tubes, so I've not actually used the L84s. So we've got a mullard valve there which we'll test, see if that's any good. And this one should be the rectifier, which should be an EZ80, and it is. That's also a mullard, so that's good. That will be going back in though, more than likely. All the ones that I've done, I have used a rectifier tube. And then we've got this beast, is also a mullard, but most of the prints off it. But this is actually an EBC81. That's what that one is. Strange one that they used. It's a single triode with two diodes in, and I can't remember what the mu on that is. Again, factor, it might be 70, something like that. You can see in here we've got the pilot light there, and usually we've got some wax capacitors in there, but they're all being cut out anyway. We've got this one to strip down as well. Remove the turntable, remove the speaker, like so, which we'll be doing there. So let's have a look at the chassis that we've already stripped down and what that actually looks like. You can see the chassis there. Small output transformer, has a bit of like a Zobel filter on there, which I've actually cut off for the minute. The reason for that one is because the capacitor will probably be leaking, which was across there on those points. There's a 10k resistor hiding under there, which you can see. You just see him there. So he'll be changed as well, because that's obviously had reasonably high voltage on it. Probably about 270 odd volts, 280 volts maybe, something like that. Voltage selector, that will be staying. And basically we've got a nice chassis to work from. We've got some good valve seats going on in there. So we just got to come up with a circuit now that that's going to work in this amp. I've got another one of these upstairs, yet another one, and I may even be stripping that one down as well. I'm trying to do all 3 chassis at once. The case is in quite a bit better condition than this one, and it could do with its face washing as well. But other than that, these make great little amps. The idea of these amplifiers is they're just used at home, and you can crank them up really loud. Well, they're not actually loud, but you can crank them up flat out and get that lovely tone that you get when you've got valve amps cranked up, which you can't do when you've got big 50-watt amplifiers in your living room, unless you want to blow the windows out, or you've got very forgiving neighbours. And look who's popped in to see us. Pink's just paid us a visit. She doesn't make as many visits these days in the workshop. She's certainly making a visit today, and she's inspecting this. She'll no doubt give it her approval. Right, I've got the turntable out, and something else that I've noticed on here, if we just hone down with the camera. So if we look at the voltage selector, we can see that, and if we just lift that up, we've got the set on 230 volts instead of, well, it was 250 in those days, but you'd obviously set it on the 250, not on the 230. I had one of these before and knew something was wrong as soon as I started testing, and obviously once I tested the heaters I realized exactly, and then I actually switched off and I thought, oh, that's set at 230, so is this one. So we need to set that on to the 250, which is near enough 240, but we need to get it off the board first. Now I've actually got acquired a bit of hardware, and you can see here from that deck, and it's always handy to save all these things. And we've got some 1/4-inch nuts there, and one's just rolled inside, but never mind. So we've got washers and things. All this stuff's really handy, and if you had to go and buy all that stuff, you know, it costs a lot of money. So sometimes I'll get an old reel-to-reel and strip it down, and I'll end up with a tenner's worth of hardware, which is £10 in American money. So it's all handy stuff, and it's all imperial, because of course everything in this country is metric. So when you're working on vintage amplifiers, you can't just go and order some new nuts because they'll be in metric. Everything's got to be in imperial. So saving all these bits for me is just an absolute result. And that's Pink making another meow there. She's on a result. She's after some treats, and we'll probably be getting a result very soon, otherwise we'll never get rid of her. So there we go. So we need now to remove this chassis from the board. We also need to cut those wires there, so we can turn it upside down now and have a proper look. You can see how this is mounted onto the board, and we will turn that board completely round like so, and then the amplifier will be mounted at the back, which means we just have to do something. We have to remove this. That's all this part here, which was ridged at the front over the speaker. So we take that off, no big deal, it just screws off. Amplifier goes to the back, and then we've got the tubes here. We've got plenty of ventilation then, because remember we're having the lid down on this. We've got ventilation holes. You can't see those on the camera, but there's ventilation holes on the side, and I do believe that, well, there's some on the back as well. So we've got this out on the bench now completely, and we're going to start removing some of the bits we don't need, which is a fair amount of it really. So this resistor capacitor here needs to go, and that, I'm not quite sure what that's doing. I think that's something to do with the tone control, you know, on these, but it's a bit like a slag. So that's going. And we'll have a bin over here for the bits that we don't want. Now some of these screws that we've got on here are useful, so we're going to take some of these. I want that. At least be useful. That noise you can hear is the rain coming down on the roof. Now we're going to leave the pilot light in, and we do leave the pilot lights in on this. And one of the reasons is is that when you lift the lid up on these, and obviously we've got the hole where the turntable used to be, leave the pilot light in, because the pilot light is mounted on that board. And the reason for that is, then if someone lifts up the lid, it reminds them that it's switched on. Although I usually fasten the lids down, but someone will always go inside them. So we're going to take these pots out as well, like so. Nice spring washers there. They're always star washers. They're always worth saving. Can never get enough of those. Essential part of amplifier maintenance are star washers. So we've got a pot there which we'll save. That's gone in the pot bin where they all go. And I'm just going to leave a bit of wire on there so it reminds me what wires are what. It just makes life easier. What else needs to go? This capacitor, obviously we won't be using that. Now these capacitors also give you a good date of when this amplifier was made, and we can see on there, it says, you might not be able to see it there on the camera, but it's December 1956 this one was made. So that's actually well, the capacitor's a bit earlier. Most of them have got a 57 date on them, so this must have been one of the first ones they did. There we go. So that's loosened that off. Now let's do some snipping. Snip that there. Oh, that wire's already off. Look at that. So yeah, it did work when I bought it though, so I don't know, maybe that's just getting up the ghost. Or giving up the ghost. I tend to use my local dialect, get up the ghost. So there's the capacitor, which we can now thread through the bottom of there, but it won't come out until we've removed this item here. Let's see if they're just relatively loose. And they're not, so we need to find a socket for those. Right, so we've got a bit more off. We've got that bracket off, and we can see here we've got the capacitor. We can see, look, December 56 on there. On that one, 3232, 425 volt surge. I'm afraid it surged its way into the bin because we won't be needing that. There's no point using a capacitor that is, well, 50 years old, more than 50 years old in fact. There's some wires there going through, so we just need to know where they're going. They would have fed the, just look, bring that round, they will have fed the motor on the turntable. We'll just snip those shy, but we'll leave those bits of wires on, but we'll be removing them later. That 4.7k there is a grid stopper going into the grid on the L84. We won't be needing that. That resistor there is 150 ohms. We just look in there. That's 150 ohms. That is the bias resistor. And this record player had no cathode resistor. Sorry, had no cathode bypass capacitor over the resistor. That's 150 ohms for the cathode. That's going to ground. But we will be obviously remedying that. So we've got a tag strip here, which I may just leave on for the time being. So we may need that, we may not. Probably won't. And then we've got a tag strip here to come off, and another tag strip there, and then that will be stripped down like the other one. And we've got all the gubbins that's come out of this, which is going in my stash. It's always useful, and you don't drop half of it on the floor, that is. You just pop that over there. So I'm going to bring this one in now that I've actually got stripped down, and if he just butches up there a little bit, so we've got a bit more space, so we'll put him in the bin temporarily. And here we go. So now we've got him in place. So how do we set these out? Well, the capacitor before, which was there, and if you look at that, it was the side of the output transformer, so that's obviously no good. So we're certainly not going down that route. But we've got these miniature boards, and these are a shorter version of what they have in the Vox AC30. I don't care for them very much, but there's really nothing else that will go in here, and they do a fairly good job. So what we do is mount it there. Now what do we mount it with? We've got an array of things here. Now I use nylon bolts, nuts and bolts for this, and one of the reasons is because the bolts go through, sorry putting the camera, is because the bolts go through the holes, whether we have 3 of them, and the components are going across the bolts. So just to be on the safe side, I like to just mount them with these, and we'll have a look. So we have these M4s that you can see there, sorry, black, oh M3, sorry, not M4. These M3 bolts, these are nylon, 30mm. You can cut them to any length you want. And then we've got some standoffs as well, which are also nylon. In the previous ones I've used metal standoffs but nylon bolts, but this time I've got the whole shebang, so that's good. There are the nuts there, you can see. So, and I've also got these standoffs as well, which I've got like on the guitar amps, where you put the nut on the standoff, and the standoff's threaded, look, you can see there. And yeah, they're good as well, so I bought those. So that's what we'll mount it with, because we don't need it to be super strong. They're quite good anyway. Once these boards are on, there's really no need for them to come off again. So you can, again with the nylon, you can run some super glue around them. They'll never come loose. So they're a brilliant idea. I don't think I'd want to use them on a huge amplifier project, but they're great for this. They work perfectly. So that gets mounted there, but obviously raised from there. And then we have another one mounted here. I think will that fit there? Yes, just so. Probably going to have another one there and put the capacitors on, and the mains wiring on there as well. What I usually do with the mains is I usually take one out the middle, so there's a bit more space between live and neutral, just to be, again, just to be on the safe side. But so we've got that, and then we're going to wire this up. As I said, PCF80. We're going to go from the pentode part of the ECF80, sorry, on this one. We're going to go from the pentode of the ECF80 into the triode, and then into the output tube. Now, another thing I want to do on this amplifier, and I've not done this before, but just to clarify what output tubes I can use in this, what impedance. The speaker's 3 ohms, I think, something like that, 3 or 4 ohms. But I want to do a turns ratio test on this transformer to find out what the primary is. So we're going to be having a look at that as well. As I say, not a big transformer, and they're obviously not that loud. We don't want them to be loud. That's not the idea of these. We want these to be turned up flat out in your living room, and not annoying the neighbours. And they work very well. I do put an extension socket on these for a cab, because you can put a 1x12 cab or something on them if you want, and obviously they are quite a bit louder then. But with those Visitron speakers that we use, we need to order some of those as well. With those Visitron speakers, they do sound really good, but they are pretty quiet. Right, enough of me waffling, we'll get on and do a bit more. Right, so we're going to do a turns ratio test on this output transformer to find its primary impedance. So you've seen this on YouTube channel. Uncle Doug's done some masterclass videos on this, and I'm sure other people have. So basically we're feeding in, and you need a variac to do this. We're feeding in AC into the primary, and we are recording the AC coming out the secondary, And basically on this meter, which is connected to the secondary, we need to see 1 volt, and whatever we've put into it on the other meter will give us the turns ratio. So let's make a start now. Just another thing, if you're doing this, obviously we've got a plug top, which you can't see off camera, which is plugged into the variac, and I've soldered the wires to the lugs on this transformer for safety. If you're tacking on or you're joining wires together or whatever, be careful, because this can be dangerous. If you're using, generally you don't usually get high volts, because usually you get to 1 volt, you might only have 30-40 volts on there. But anyway, we've got that soldered on, so we know it's nice and safe. So we begin to apply some voltage, and we don't seem to be getting any voltage. Or am I not connected on properly? Or is the meter not connected on properly and it's not? Look, silly me. I would have used a more serious word, but not while I'm online. Let's just get that on there. It doesn't want to go, does it? Let's try it that way. There we go. That's better. Now it will work. And yes, already got 9 volts, so we start to go up. Got 16 volts, you can see there, and we're just working his way up. It's quite high. There's our 1 volt. So just come down till we get to 1 volt. That's exactly 1 volt, and you can see we've got 38.5. So that tells us that we've got a turns ratio of 38.5 to 1. She's gone to 38.6, but 38.5 will be near enough. So we need to switch all of that off now. Having got our 38.5 that we've got there, we times that, we square it, so 38.5 times 38.5 comes out at 1444. So 1444 times 4, that comes out at 5766, which is just a shade over a 5k primary. So I think at 4 ohms we could probably call that 5k primary there. So we've got the board mounted now for the components, and you can see if I just turn it that way a bit. Let's just if we zoom in just a shade, you can see, there we go. So I've used these nylon bolts to fasten these in, and as I mentioned before, having components going over the bolts, if they're metal, for instance, I can now use that lug on there, where if that was metal, a metal bolt, I wouldn't be able to use that lug, so it'd be wasted. So that's great. So I've got those done. I put one in as on here, if we just slide it across. So I've got one there which is going to have the power capacitors and the AC coming in. So the AC will be on these 4. You can see I've took a lug out just to keep that space, just because it's the AC, because I can. Then I've got 3 lugs there just to give me a bit of a break, bit of a space between DC and AC, because I'm going to have both on that board. Now, this is the problem with doing these, is that they're so small, you're kind of making allowances. Normally you wouldn't have any DC, this AC this close to the DC, but it shouldn't be a problem. It hasn't been on the others. And of course we've got the mains cord retainer there that we always use, so we've got that in as well. And obviously we're going to put a new power cable on it. If we look at the back, we can see the screws there, and the bolts there, and I've got the nuts on there, and they just need a dab of super glue on them. But unfortunately I had got some, but you know what it's like, the super glue, it's all dried up, so I've got to get some more. And those never need to come off, so there's no problem with gluing those, because it's not like they're going to be coming off. You don't need to take them off. All the access to the components are on top of the board, so there's no problem there. Right, we've been doing a bit more on this Bush RP20 chassis. Just have a bit of a look at what we've done. So we've got an inline fuse holder. Not a major lover of those, but unfortunately there just is nowhere else to put a fuse. These are the first node, these two, and they are 100 microfarad at 250 volts wired in parallel. You're trying to use a few capacitors up that I've got. So these are low ESR. So we've got four, that comes out at about 45 microfarad with those in series, which is fine for the EZ80. Remember, we can't go over 50 microfarad on an EZ80. The second node is there, and the reason that I've got this RLEW second node here and your first is because these capacitors won't fit under the transformer, so they've had to go there where there's space. So we've got 33 on there at 33 at 350. For the second node, that's for the screens. We've got a 1k drop-in resistor between node 1 and 2. So if we move down now, this, we've got this 22 microfarad there. That is for the pentode of the ECF80. And look, the work inspector's popped in to see us just to check the work. He's having a good look. Yes, I think it's passed. All she's interested in is getting some food. That's what Pink's interested in, but there you go. She's popped in to see us again. She doesn't pop in so often now, but she has paid us a visit today. Got some resistors, capacitors and stuff on here, and we've finished all the power supply section of this now. So as we said before, that's first node, second node, third node 22 microfarad. That's for the pentode, for the plate on the pentode. Then we've got 10 microfarad for the screen on the pentode and 10 microfarad for the triode section of the EF80 that we're using. 2.2 drop-in resistors down there, because remember, we've not got a massive amount of voltage on this, and so we're just keeping all the drop-in resistors fairly low. So we've got to make sure we've got enough voltage up this end. Now, if we just work our way down, 1.5k, that is there. That is the grid stopper for the output tube. And then we have got that is a 100k plate resistor, and that's for the triode. And we have got, what is that? Just struggling to see looking through the camera. That is a 3.3k, that's the cathode resistor for the triode. We've got 22 nanofarad there, which is the coupling capacitor, which is going from the plate of the pentode to the grid of the triode. Then we've got 100k 100k there for the plate on the pentode, and we've got 510k for the plate on this. We've got 510k for the screen on the pentode. Then we've got 47k for the grid stopper into the first stage of that pentode, and we have a 3.3k for the cathode there. So that's what we've done so far with all of that. I've cleaned off this valve socket, this valve seat, which took me about 20 minutes because there was endless wire wrapped around these last three, because remember this was a double diode triode valve, and they'd put the diodes down to ground, so they just wrapped all the wire around. So cleaned all those off. It probably would have been quicker to install a new valve seat, but got this thing about recycling, and then I'd have to drill the rivets out and things. So persevered, we've got that done. The output section, bar this cathode resistor on the output tube, but that's going to be cut out anyway. I've left that in there, but closer inspection says that's had a bit of heat. We may not need that value anyway. So what I'm going to do is cut that out, and I'm going to jumper one in when we fire this amp up. But that's all wired up, all that section. All the output stage now is wired up. We just need to get the AC in there from the power, get the power cable in, and we need to wire up this tube socket. And then this space here is for the tone stack. Now I'm not quite sure which tone stack I'm putting in this, but I might put a James stack in, and I've used that on one particular amp. I actually put that in a Fender Champ design that I did before I started doing the channel, and it worked really well. So I've not used that since, but I may try that again just on this amplifier. So I've left that space. Now what I tend to do with these amps, because putting them in the case requires bringing leads, we have to bring screen cables up to the lid, and then they go into they go to the pots which are on the lid. So what I tend to do with these, because I want to get this amplifier right before I start wiring all that up. Otherwise I finish up, I've got the lid up, I've got the amplifier propped up on the case, and I'm faffing about trying to bias it and things. So what I'm going to do, I'm not going to put the tone stack in straight away before I fire this up. I'm just going to connect from the last stage of the preamp and just connect straight to the output tube, and then I'm going to bias this amp and get it all running properly, making sure it's running right. So it reminds me, we are missing a grid leak on the output stage, so which could be anything from 220k up to 460. So I'm not sure where we're going to go with that yet. So that's what I'm going to do, and then I'll bias this amp up and get it running spot on, and then it's just a matter of, we'll do the tone stack and test it again, and then we'll get it into the case, and then yeah, and then see what it sounds like. The speakers came this morning, so we've got those. So here's one of the speakers that we're using. We'll just flip that over and not look it upside down, do we? So there, Visiton. These are German. FRS 8 4 ohms. These speakers are 3" in diameter, just a shade over, or 78mm if you want to be picky. And these work great. We have a pair of these and they work really well. So they are 30 watts each. I ordered those on the first one I ever did, and I just thought, I'll try those, and it was just sheer luck. They sound mint. So that's what we're using, and I've actually just ordered 8 of these because I've got a few more of these record players to do. So I've ordered enough to do all of them. Yeah, and as usual, just when you thought you was going to get something done today, you realise that maybe you're not, because Pink's come to inspect the work, and she's not going to leave me alone until she's had some food. I've got the EZ80 plugged in now. We've got AC. We're going to check for a bit of DC now. This is a bit different to just testing for AC, because having a rectifier tube, it means I've got to get that conducting. So I've got to put a fair bit of voltage in this before we start to see anything on those capacitors. There's no other tubes in it. We're just looking to make sure we've got voltage where we should have. So we're just starting to add some voltage in. I'm just keeping an eye on the amp meter. It's not going up at all, so no shorts. 60 volts on the variac, 69 milliamps on the amp meter, and obviously, of course, that includes the variac, which will be obviously drawing current. I won't think we'll get anything from that EZ80 until we're up to about 120 volts, which is about half of the UK mains voltage. I could be wrong though. I think, oh no, look, there we go. Something's occurring. We've got 79 volts on the variac we're drawing, yep, 80 milliamps. Let's check it on there, and we have got voltage there. So we don't need a lot to test this, so we'll leave that where it is and we'll let that go up. Till it settles. Just going to bring that voltage down a little bit on the variac. So you can see that's going up now. Right, so let's move down the nodes. Got 80 volts now. I'm just going to drop that variac down to 65 volts. Slow that rate of that increasing, and we have done. Right, so we should have roughly the same voltage either side of all of these. Yep, because of course it's going up all the time. Nothing there, that's good. And then check there, yeah, and there, obviously, yeah. Oh, and the ground's come off on the meter. Never mind. So we check there, yep, 89 volts. Should have the same there. Yep, 89 volts. So now we're down to the plate resistors, which we're going to go there. Yep, 88. On that leg there. Yep. And then on the screen of the, yeah, pentode. That's good. And then we'll miss one out. That one. Let's miss that one out there. Yeah, so that all looks good. Voltage there. I'm struggling to get in here because of the camera in front of me. I don't normally work on this bench with the camera. Yeah, got voltage there. So that's all looking good. Whoops, sorry about that. So what we're going to do now is pop some tubes in it. Right, we've got we should be ready to go. We've got the tubes in, and I've just put a second-hand mullard in EL84 just to get us going. And there's the ECF80. That's brand new. It's just come straight out of the wrapper. We're making the Tone Priest jealous. He's very jealous of all my mullard tubes. I'll have to do a video on them because I've got quite a lot. They're all new old stock. Right, I've got a meter on the bias just to monitor that, but that's off camera. You can just about see it protruding there. So I've got a grid leak resistor in there on that 1 meg on that triode stage coming in. I've got a 430 ohm cathode resistor tacked in on these jumpers. I've gone quite high to start with. I know roughly what these will need with an EL84, and so I've gone a bit higher while we're testing. And I've got this here, which is fastening the coupling cap from the triode stage of the ECF80 into the grid of the EL84. So with all of that, we shall begin. So we'll go back up to about 70 volts on the variac, just till we start to see that EZ80 conducting, and we should see a bit of DC on there. If I still got that, well, we would if I'd got it connected, wouldn't we? We haven't. It's here, but not to worry. So we'll go on to the first node, which is there. And already you can see we've got 32 volts coming in there, although that some of that could be left over from before, because of course we didn't have the valves in, so the caps won't have discharged. Something you always need to watch if you fire an amp up without the tubes in. there will always be voltage left in the capacitors, and it takes a long time to drain. If the valves are plugged in, then it will be conducting, and as it turns off, it'll eat away some of the voltage, although that's not always the case. You have to be careful. So always check the capacitors that are discharged with your meter, or you might get a nip. You can see that's going down because it's the meter's draining the capacitor. The voltage has not started coming in from the tube yet, and now suddenly it's starting to go back up again because that tube's beginning to conduct. So we're going to sit at about 80 volts. In fact, I'll tell you what I'm going to do. It would help if I put a speaker on it. Duh. Right, we're back with the speaker connected now. What a plonker. Just remembered in time there before I'd got that any conductance on the valves or the tubes. So let's go back to our friend 80 volts there and just wait patiently for that to start coming up again. You can see it's still the meter's discharging it again because we didn't get too much voltage in it. Just give it another 10 volts, madam. There we go. That's got it conducting, so it's beginning to go up again. So we've got 90 volts on the variac, and we're just letting that steadily come up there till it gets to a resting point. While that's going up, let's have a nosy at the old 75 milliamps. So that's nothing. There we go, 85 volts and counting. So it's just beginning to level out now. So we've got 90 volts going in and 87 at the moment. Although I think that variac doesn't get accurate until it gets up to about 150 volts. Right, let's work down the line. 88. Let's try down here. 83. So there's some slight conductance going on there. I'm just going to go up to 110 volts now, which will be your mains voltage in the US. It's just shy of halfway point here. Now that's going up again. I can hear sound out of the speaker already, so that's good. So I've got 132 volts there. Let's go right back down here to this node. 60. Oh no. Where are we? There, not there. Sorry about knocking the camera again. Strike there. 125. 137. That's working a treat. It is. And I've got 1.2 volts on the bias. So we're going to go up now to 140. Four volts on the bias. See what we've got now. Node 1. 183 volts. 179 on node 2 for the screen of the EL84. Right, let's just have a little. Yeah, causing it to oscillate a bit, but that's now better. So we're not too concerned about that, because obviously that's not what we're concerned about, is making sure that this amp is running. And we haven't even got the original output tube in, so we're not even bothered about getting it biased. We're just bothered about getting it running, and it is running. So we've just got that bit of oscillation trouble there, but that's nothing to worry about. So it runs okay. As regards, we've got the power going through the nodes. And there we go. Now we've got full voltage on it. That oscillation stopped and it's running. Obviously it's a bit noisy. Remember, it's got no input on it and so on. But there we go, it runs.